Welcome back everyone. Previous videos looked at why do we have sine, why do we have cos, why do we have tan. If you want to go back and look at those, if you haven't seen them, you found this video first, they're in the previous videos. You can even just go to the playlist on my channel and the playlist has them in the correct order. So you can have a look and go back if you need to go back to them. Okay, let's look at the situations. We've got a sine, we've got cos, and we've got tan. So on your calculator you have a sine button, you have a cos button, and you have tan button. The sine and the cos and the tan store the fractions, actually they store the decimals for each of these situations. Three of these triangles have got different information on them. I actually have drawn them fairly accurately, not that I need to be able to have them deadly accurate, just fairly accurate, gives an idea. So I look at this triangle here. I know that this side here is called the hypotenuse. I'm just going to put H now for hypotenuse instead of writing HYP or whatever. We normally could write the whole word. Going across from the 52, I've been talking about this a lot. If we start at an angle of 52 and I look across, I see the opposite. Again, I'm going to say it one more time, might say it more. I look across the road, I see the people opposite from me. So starting here, I'm looking across to the opposite. So this is like a little me. Sometimes I like to do a little mini me. So there's little mini me and I'm looking across to where the X is. So the more we can get things that work for your brain so you can remember what it is, so you don't have to study so hard on it and it just sticks in your brain. Let's have a look. This is called the O for opposite. This one is next to the 52 and we use the word. It's right there next to the 52, so is the hypotenuse, it's next to the 52, but that's already got a name called the hypotenuse. So historically, people knew they had a name for the hypotenuse, they had to figure out a name for the other sides. And the system was, that one's across from it, so they called it the opposite. That one's next to it, and they used, instead of calling it the next to, it's a bit weird to say next to. How would you write it? It would be an N. You say adjacent, which is an A. So the word adjacent starts with A. So let's have a look at the triangle. It's got an O, it's got an A, it's got something written on that side. So we're going to use the information, or find the information. In this case, we're going to find the length of that side. So it's all about lengths. We're going to get the length of that side and we're going to figure it out using a 52 degrees and a 14 centimetres. So this is information on the O and this is information on the A. So if I went across here, I ticked O, I ticked O, I ticked A, and I ticked A. Out of those three possibilities, out of sine, out of cos, and out of tan, which one has the most number of ticks? Which ones have the most number of information? There's not enough information to use sine, there's not enough information to use cos, so this question is going to have the information stored in our calculator under the tan button. So I can write down the formula, it's always going to be tan theta. Now that's the numerator and that's the denominator. So people talk about SOHCAHTOA as a method of remembering them. People have words and all sorts of systems they use. I do have the other thing I like to mention. Both of these come down to the right angle. We're not using the hypotenuse, it's going to be a tan question. So this is a nice little shortcut because actually a little secret, it's harder to design sine and cos questions and they're not as commonly used in life as we have tan. So tan theta is those two there and I'm going to write it as the opposite over the adjacent. So there's tan theta, there's numerator over the denominator. There's so many ways people use triangles and all sorts of things. So I replace the angle by the 52. I replace the O by the letter X, and I replace the A by 14. Got an equation to solve. How do I get rid of a divide 14? I go times 14 this side, I go times 14 that side. How many times does 14 go into 14? And it's a once. So that becomes X equals, and I pick up my calculator and I go, make sure it's set on degrees, and I got 14 times by, press the tan button, and the button angle we're using is 52 and I get 17.9. 17.9. So the length, this means the length of that side on that triangle would be 17.9 centimetres. So if I go through the others, I don't want to take so long, I don't want the video to stretch out. So this one's called H for hypotenuse. That's other one is right next to the 39, that's A for adjacent. So if I go back to here and I remove the ticks from before, now I'm talking about O and an A and a H. So there's an A, there's an A, there's a H and there's a H. Which one has the most information? It's not really about most information, but it's pretty obvious it's the most. It's also about enough information. So on this one I'd put the cos of theta equals A and H. So replace the angle there, remembering that the cos of 39 is pre-stored into your calculator. And then we have the A gets replaced by the letter X, and the H is the hypotenuse replaced by the 30. How do I solve an equation when it says divide by 23? If I times this side by 23, I times that side by 23. I pick up my calculator and I've got 23 times by the cos of 39, which I could have worked out previously, but I don't want to. And that's about 17.9. So now I'm going to shortcut. Instead of writing it this way, I'm going to swap the x over to here, because 23 into 23 goes once, so I can just write x. And the answer was 17. I'm going to write only to one decimal place. So I could have written more numbers here if they want more accuracy. If they say they want one decimal place, a lot of people talk about 1 dp, then I'm only been giving it to the nearest one decimal place. So on this one here, if that was 23 and that was 39, that was 17.9. One to go. So what I've done is looking at the three. This question was a tan, this question was a cos, so this one's obviously going to be a sine. But let's go through it. Starting at that angle there. This one here is called the hypotenuse. Now remember, across from here is called the opposite. So what letters am I using this time? I'm using obviously the O and the H. Some of you won't need to do this. You go, there it is, the O and the H. O and the H, the O and the H. So this time the S, the sine, has the most information. So it's the one with sufficient information to do the question. O is the numerator, H is the denominator. O goes on top, H goes on bottom. So this saves a lot of you needing to memorise it. Gives it all to you in one simple expression. So what have we got? Replace the angle by 53. Place it opposite by an x. And then we've got the hypotenuse, which is replaced by 29. And I wanted you to see this for all of them. On this question, we had divide by 14 times by 14 times by 14. On this question, we had divide by 23 times by 23 and times by 23. On this one, we had divide by 29, so I needed times by 29 times by 29. That's about equation solving, which has got its own problems, not trigonometry. So in the middle of trigonometry, we're solving equations. We'll solve equations everywhere. How many times is 29? Then go to 29 once, so I can just put 1x. Then I pick up the calculator and go 29 times by the sine of 53. And I get 23.2. And a lot of people would put 1 dp. Old school, we used to write that in, and then we put that it was also centimetres. And that's the length of the side. So this is used under the right circumstances to calculate the length of one side if we know the length of another side and an angle. So look at this one, we've got a side and an angle gives us that side. A side and an angle gives us this side. This one, a side and an angle gives us that side. So it's always being careful which one you need to find. In the next lot, I'll need to start looking at what if we're finding a different side, or what if we're finding the angle. I actually prefer to look at the angle next and find out what if we're figuring out the angle from the triangle. Thanks again.